Find the particular solution for the differential equation y double prime plus 3y equals -9. So in this case we have a non-homogeneous differential equation, where the right-hand side doesn't equal 0, and you can solve this a bunch of different ways. But for the case of this problem, let's do method of undetermined coefficients, where we first need to evaluate y homogeneous, or at least the roots of it. So we take y double prime plus 3y now equal to 0. And for the roots, we form our auxiliary or characteristic equation, where r equals the number of derivatives being taken on y, so y double prime is r squared, and 3y is no prime, so we just call that 3, equal to 0. So solving for r squared equals -3. Taking the square root, we have r equals 0 plus or minus rad 3, and we call that r homogeneous, times I, where I is rad -1. This means that alpha h equals 0 and beta h equals rad 3. Now for the particular portion yp, we must first observe the general format, which takes the form of ay double prime plus by prime plus cy equals c times t to the power of m e to the r particular t. So a, b, c, and capital C are all constants, and we don't even have a y prime term, so we have to focus on t to the power of m. Obviously, on the right-hand side, there is no independent variable even there, so we call that m equals 0. So t to the 0 would just be 1, and that would allow for every other variable to take form. Likewise for e, there is no e term, so we can call r particular equal to 0, since e to the 0 is 1, and all that's left is this constant here, c, which we know is -9. And we also have to check to see if rp equals rh, because if it does, then we have a repeated root, and we have to bring everything up by a power of t. Does 0 equal plus minus rad 3i? Obviously not, so rp doesn't equal rh, and we can call this term s equal to 0, which is necessary when we form the equation y particular equal to t to the power of s times a decreasing polynomial of degree m, where we have a sub m times t to the m plus a sub m minus 1 times t to the m minus 1, so on and so forth, until a sub 1 times t plus a sub 0. And this is all multiplied by e to the rpt. As we said before, s equals 0, so we take t to the 0, which is 1, and all we have is m equals 0, so we don't even have an a1t term or anything above that power, where a's are all constants. All we have is a sub 0, so we just put in a sub 0. And we also said rp was 0, so e to the 0. And reducing this, we have a sub 0. So now we know that y particular equals some constant a sub 0. All we have to do now is do two derivatives to get up to y prime, and then plug that in and see what we get. So yp prime equals 0, since the derivative of a constant is 0, and doing another derivative, the derivative of 0 is 0 again. So now we plug into y double prime plus 3y equals -9. So y double prime, yp double prime is 0 plus 3 times y, which was a sub 0, and we don't even need yp prime. And this equals -9. And this is probably the most simple version of this problem you'll ever see, since there's only one variable and one operation needing to take place, where we have 3a0 equals to -9. So all we have to do is divide by 3, and this means that a sub 0 equals -3. And looking back to what we said here, y particular equals a sub 0. So this means that yp equals -3. And that is our solution for this question. Technically, this is all you have to do, but in some problems they might ask you to find ygen, which is the whole general solution, which is the combination of yh plus yp. And just for the sake of showing you what that is, we can use this alpha equals 0 and beta h equals rad -3 to form the expression c1 cosine of rad 3t plus c2 sine of rad 3t. And all we have to do is add this -3, since it's plus yp, so -3, which effectively transposes this whole expression down by 3, but all the problem asked for was just this step here. I hope this helped. If it did, please like and subscribe, and I'll see you in the next video.